Hello students, welcome to Yupp Master. This is 11th class IIT English Live. I am Radha Krishna, mathematics teacher. We are going to continue our topic quadratic equations and expressions. Today we are going to discuss quadratic expressions and inequalities. Just I will revise few points in the discussed in the last class. The graph of y is equal to ax square plus bx plus c is a parabola having its axis parallel to y axis, and if a is greater than 0, the concavity is upwards. It is a parabola. Y is equal to x square plus bx plus c is a parabola having its axis parallel to y axis. All of you know the shape of a parabola. This is called a parabola. If a is positive, then the concavity of the parabola will be upwards. This is called concavity. All of you know about concave lens and convex lens. If the shape is like this, it is convex. If the shape is like this, it is concave. So this is called concave side, this is convex side. So here the concavity is upwards. When a is positive, the concavity will be upwards, and this point is called vertex of the parabola. Through the vertex, if you draw a line parallel to y axis, it is called axis, and the parabola will be symmetric about its axis. Okay. Next, if a is less than 0, then the concavity will be downwards. The parabola will be like this. Again, this is called vertex and this line is called axis. Now, let us see various positions of the parabola. If a is greater than 0, then concavity will be upwards. It can be in any one of these three positions. If delta is greater than 0, then the quadratic equation, this is the graph of y is equal to ax square plus bx plus c. Okay. If delta is greater than 0, then the quadratic equation ax square plus bx plus c is equal to 0. Will have two distinct real roots. Then by putting y is equal to 0, you are getting two distinct values of x. That means the curve y is equal to ax square plus bx plus c intersects the x axis at two distinct points. If the roots of this equation are alpha and beta, then this point will be alpha 0, this point will be beta 0. Okay. Now let us take another situation. Delta is negative, discriminant is negative. Then the roots of this quadratic equation are imaginary, non-real. Then putting y is equal to 0, you are not getting any real values. That means the graph does not intersect the x-axis. The graph will be completely above the x-axis. Okay, but still axis will be parallel to y-axis. Now another situation, if you take delta is equal to 0, then the roots of this quadratic equation are equal. Then if alpha and beta coincide, then this graph touches the parabola, touches the x-axis. At this point, at the vertex, the graph touches the x-axis. Okay. Next, if a is less than 0, these three are the possible cases. This is the graph of y is equal to ax square plus bx plus c. If delta is greater than 0, then taking ax square plus bx plus c is equal to 0, you will get two distinct real roots, say alpha and beta. Then the graph intersects the x-axis at two distinct points, alpha comma 0 and beta comma 0. If delta is negative, then the graph does not intersect the x-axis, because if you put y is equal to 0, you are not getting real roots, you are getting non-real roots or imaginary roots. then the graph will be completely below the x-axis. If delta is equal to 0, then these 2 points coincide, then the graph touches the x-axis at its vertex. Okay. Now, considering these 3 positions when A is positive, you can observe that the value of y can vary up to infinity. In all the cases, y can take values up to infinity. Y coordinate of any point on the curve can reach up to infinity. But there is a minimum value of y. It occurs at this bottommost point. At this bottommost point, the value of y will be minimum. And how to get the minimum value of y? You can write the quadratic expression as a into x square plus bx by a plus c by a. Now, you can write this as a perfect square. If you want to write it as a perfect square, you should write x square plus, write bx by a as 2 into b by 2a into x. This is in the form of a square plus 2ab. Then by adding b by 2a whole square, it becomes a perfect square. So, adding b by 2a whole square, that is b square by 4a square, then we have to subtract b square by 4a square. We have to subtract b square by 4a square. So, minus plus c by a is there, c by a minus b square by 4a square. Now, I will write it on the next page. Ax square plus bx plus c is equal to what? A into x square plus 2 into b by 2a into x plus b square by 4a square plus c by a minus b square by 4a square. Now, first 3 terms will become a perfect square. It is equal to a into, how can you write the first 3 terms? X plus b by 2a whole square and remaining term is independent of x, constant. If you combine these two, 4a square is LCM, numerator will be 4ac minus b square. Now, you can write it as a into x plus b by 2a whole square plus multiplying by a, the second term becomes 4ac minus b square by 4a. Okay. Now, we want the minimum value of this quadratic expression. We know that minimum value of a perfect square is 0. X plus b by 2a whole square is always greater than or equal to 0 for any real value of x. All of you know this. Now, if a is positive, then you can multiply both sides by a, still it will be greater than or equal to only. So, I will multiply by a and write it like this. Now, this is constant. If you add this constant on both sides, a into x plus b by 2a whole square plus 4ac minus b square by 4a is always greater than or equal to 4ac minus b square by 4a. But this is what ax square plus bx plus c. So, we get ax square plus bx plus c is always greater than or equal to 4ac minus b square by 4a, which is a constant. This is greater than or equal to this for all real values of x, for all x belongs to R. So, if you take the graphs, in all these three positions, the minimum value of y or the quadratic expression is given by 4ac minus b square by 4a. So, finally, the conclusion is if a is greater than 0, the minimum value of ax square plus bx plus c is 4ac minus b square by 4a. All of you should remember this formula. And for what value of x the minimum value occurs? The minimum value occurs when this is equal to 0, because this x whole square must be equal to 0, that is the minimum value. When is this equal to 0? When x is equal to minus b by 2a. So, this minimum value occurs at x is equal to minus b by 2a. Now, if you are familiar with differentiation, we can get it very easily. You know that if you are familiar with differentiation, derivative of a function at any point represents the slope of the tangent. If you differentiate this y and substitute some point here, then you are getting the slope of this tangent. At the bottommost point, if you draw a tangent line, then tangent will be parallel to x axis in all the cases. At this bottommost point, tangent will be parallel to x axis. If a line is parallel to x axis, then its slope is 0. So, at this bottommost point, dy by dx will be 0, because dy by dx is nothing but slope of the tangent. If you are familiar with these things, differentiation and that derivative of a function is equal to slope of the tangent, if you are familiar with all these things, you try to understand. Otherwise, you ignore it, you can understand it later. Already have explained the proof. Now, at this point, dy by dx will be 0. What is dy by dx? 2ax plus b. If it is 0, what is the value of x at this point? Minus b by 2a. So, x coordinate of the bottommost point, which is called vertex, is minus b by 2a. Then, how do you get the value of y? If you want y, you substitute this x coordinate in this equation. Y is equal to a into minus b by 2a whole square plus b into minus b by 2a is minus b square by a plus c. If you simplify it, you will get 4ac minus b square by 4a. This is very simple. This proof is very simple. Otherwise, you have to understand the proof like this. So, if a is positive, ax square plus bx plus c will have a minimum value. At what value of x? At x is equal to minus b by 2a, and the minimum value is given by the formula of 4ac minus b square by 4a. Now, let us take less than 0. If a is less than 0, you can see the graph in all the 3 positions. The value of y can reach up to minus infinity in all the cases, but there is a maximum value here. At the vertex there will be a maximum value. How to get the maximum value? This maximum value or this maximum value? You take the same steps. First you write ax square plus bx plus c like this. Now first you take x plus b by 2a whole square greater than or equal to 0. That is true for all real values of x. Now when a is negative, if a is negative, if you multiply both sides by a, then a into x plus b by 2a whole square will be less than or equal to 0, because you are multiplying by a negative number, inequality will change. Greater than or equal to becomes less than or equal to 0. Then adding this constant, this will be greater than or equal to 0 becomes less than or equal to 0. By adding the constant, we get this is less than or equal to this, but this is nothing but ax square plus bx plus c. We get all these greater than or equal to becomes less than or equal to. So add, this is ax square plus bx plus c less than or equal to 4ac minus b square by 4a for all real values of x. So it is the maximum value. For any value of x, this expression cannot exceed this fixed number. So it is called maximum value or greatest value. So if a is less than 0, if a is less than 0, the maximum value of ax square plus bx plus c is given by 4ac minus b square by 4a, which is same for minimum value in case a is greater than 0. And this minimum value, maximum value also occurs when x is equal to minus b by 2a, because when the maximum value occurs when this is equal to 0. This must be equal to 0. For what value of x? X is equal to minus b by 2a. So you can note down these statements. Now the same thing can be obtained by differentiation. By differentiation, at this point tangent will be parallel to x-axis in all the cases. So at the maximum point, dy by dx will be 0. If dy by dx is 0, dy by dx is 2ax plus b will be 0. We get x coordinate as minus b by 2a. Same. Substituting minus b by 2a in place of x here, this becomes 4ac minus b square by 4a. So the coordinates of this vertex are minus b by 2a comma 4ac minus b square by 4a in all the cases. Okay. Whether a is less than 0 or greater than 0, the formula for vertex is this. So when a is negative, then the quadratic expression will have a maximum value. Okay, the same points. If a is greater than 0, the minimum value of ax square plus bx plus c is 4ac minus b square by 4a. If a is less than 0, the maximum value of ax square plus bx plus c is 4ac minus b square by 4a. If a is less than 0, maximum value is this. There is no minimum value. It can vary up to minus infinity. When a is greater than 0, this is the minimum value and there is no maximum value. It can go up to infinity. Okay. Next points. Again, observe the graphs. If a is greater than 0, graph will be like this, or it may intersect the x-axis. I am considering these two cases. In these two cases, if you take this case, graph is completely above the x-axis means delta is negative. Then how is the graph? It is completely above the x-axis means the value of y is always positive. All of you know that above the x-axis for any point y is positive. So, whatever value of x you take, the value of y will be positive. So, the same point is, if a is greater than 0, delta is less than 0, then the expression ax square plus bx plus c is greater than 0 for all x belongs to R. Now, the converse, whenever ax square plus bx plus c is greater than 0 for all x, then it is possible when only when a is positive and delta is negative. So, all of you carefully remember these points. Suppose the graph is like this, touching the x-axis. Okay. If a is greater than 0 and delta is either less than 0 or equal to 0, then we get ax square plus bx plus c, the value of y is greater than or equal to 0. The equality occurs only in the second graph when delta is equal to 0. Ax square plus bx plus c is greater than or equal to 0 for all real values of x. Converse, if ax square plus bx plus c is greater than or equal to 0 for all x belongs to R, then a must be greater than 0 and delta must be less than or equal to 0. So, you have to remember these points when a is greater than 0. The sign of the quadratic expression is always positive in these two cases. Next, you consider this case and this case. If a is less than 0, when the graph is downward parabola, a is less than 0. In this case, delta is negative. That is why graph is completely below the x-axis. In this case, a is negative, delta is equal to 0. If you take the first case, you can see that the value of y is always negative because the graph is completely below the x-axis. So, if a is negative, delta is negative, then the quadratic expression is less than 0 for all real values of x. Now, the converse, if whenever ax square plus bx plus c is negative for all real values of x, it is possible only when a is negative and delta is negative. Next, if we combine these two cases, if a is less than 0, delta is less than or equal to 0, then ax square plus bx plus c is less than or equal to 0, equality is missing, less than or equal to 0 for all x belongs to R. Converse, if ax square plus bx plus c is less than or equal to 0 for all real values of x, then the necessary condition is a is less than 0, delta less than or equal to 0. Now, if delta is greater than 0, then there are two situations. When a is positive, delta is positive, the graph intersects the x-axis at 2 points, say alpha, beta. If a is negative, delta is positive. A is negative means graph is downward, delta is positive means graph intersects the x-axis. Let the points of intersection be alpha 0, beta 0. Now, let alpha and beta be the distinct roots of ax square plus bx plus c is equal to 0. Now, you observe the sign of y. These are the graphs of y is equal to ax square plus bx plus c. Now, observe the sign of y. When x lies between alpha and beta, here y is negative. When x lies between alpha and beta, here y is positive. Okay. So, when A is positive, Y is negative. When x lies between alpha and beta, when A is positive, the value of the expression is negative. When A is negative, expression is positive. So, A and expression, A and a Y will have opposite signs when x lies between the roots. When x is less than the smaller root or greater than the larger root, then when A is positive, Y is positive, graph is above the x-axis. Here, when A is negative, Y is negative. That means, if x lies between alpha and beta, A and Y will have opposite signs. When x does not lie between alpha and beta, A and Y will have same signs. See, if A and Y means the expression, have same sign, then from the previous graphs, if A and Y have same signs, means this interval or this interval. Here A is positive, Y is positive. Here A is negative, Y is negative. What is the interval of x? X is less than alpha or greater than beta, that is the interval of x. Whenever you notice that x square coefficient and the expression have same sign, then x must be less than alpha or greater than beta. But if A and ax square plus bx plus c have opposite signs, then x lies between the roots. Alpha is less than x, less than beta. Okay. Now, simply the same statements, suppose x minus alpha and x minus beta less than 0. X square coefficient is positive. Whole expression, this is a quadratic expression in factorized form. X square coefficient is positive, the expression is negative. So, A and ax square plus bx plus c have opposite signs. Then, what is the solution? Alpha less than x less than beta is the solution of x or interval of x. If x minus alpha into x minus beta greater than 0, then x square coefficient, if you expand, x square coefficient is positive, the whole expression is also positive. So, according to this first statement, x is less than alpha or x is greater than beta. A simple example I will explain. Suppose minus x square minus x plus 2 is less than 0. It is the question. The question is solve. Then what will you do? First you check discriminant. What is the discriminant? B square minus 4ac is positive. So, there are distinct real roots. There are distinct real roots. Find them. According to the formula minus b plus r minus formula, 1 plus r minus root over b square minus 4ac means 9 by 2. B square minus 4ac is 9 by 2. So, that is 1 plus r minus 3 by 2. If you take minus sign, you will get root as minus 1. If you take plus sign, 1 plus 3 by 2 root is 2. Minus 1 and 2 are the roots. Now, x square coefficient is negative, expression is also negative. So, A and expression have same sign. Then what is the solution? What is the solution of x? You will write x is less than alpha. Alpha means smaller root minus 1, or x is greater than 2. This is the solution of this inequality, or you can write the interval of x like this. X belongs to minus infinity to minus 1 union 2 to infinity. This is the way we write the answer. Okay. X can take all real values from minus infinity to minus 1 as well as 2 to infinity. Suppose equality is also given in the question, then this expression can be equal to 0. This will be equal to 0 for x is equal to minus 1 or 2. Then we have to write equality here and here. Then we have to change this bracket as closed bracket. Square bracket represents closed bracket. That means last value is also included. Okay. So this is how we solve quadratic inequalities. And one more point, suppose the question is solve 2x square minus 3x plus 5 greater than 0. Similar question. Here first you check the discriminant. Discriminant is negative. B square minus 4ac is 9 minus 40, negative. When discriminant is negative, the graph of this quadratic will be completely above the x-axis because a is positive. Then when is it positive? When its graph is completely above the x-axis with concavity upwards. Concavity is upwards because a is positive. Graph does not intersect the x-axis because roots are imaginary, delta is negative. Then when is it true? For all real values of x it is true. Then you will write the answer as x belongs to all real values minus infinity to plus infinity. Okay. Suppose the question is given as solve this quadratic less than 0. You can notice that it is never less than 0. Then you will write the interval of x as null set. Okay, understood? Now let us solve problems on these theory points on quadratic expressions. Solve x square minus 6x plus 8 greater than or equal to 0, comma minus x square plus 5x minus 4 also greater than or equal to 0. When two inequalities are given, we have to find the common interval. This inequality will have a solution, this will have a solution, but both must be true, means we have to take common interval of the two solutions. Let us solve separately. X square minus 6x plus 8 greater than or equal to 0. First you check the discriminant. Discriminant is positive. B square minus 4ac is positive. So there will be real roots. You can find the real roots by using the formula minus b plus r minus root delta by 2a, or if you want you can factorize. This can be easily factorized as x minus 2 into x minus 4. Is it not? So there are two distinct real roots 2 and 4. Now x square coefficient is positive, the expression is also positive. When is it possible? When x does not lie between the roots. So the solution is equality is also there. So x is less than or equal to smaller root, or x is greater than or equal to larger root. This is the solution of the first inequality. Now let us solve the second. Minus x square plus 5x minus 4 greater than or equal to 0. If you check the discriminant, it is positive. So it is factorizable. Now if you want, you can multiply both sides by minus sign. Here initially x square coefficient is negative, expression is positive. X square coefficient and expression have opposite signs. Then x lies between the roots. X lies between the roots. How to find the roots? If you take minus common, we can write it like this. Now you can easily factorize this as x minus 1 into x minus 4 greater than or equal to 0. Roots are 1 and 4. X square coefficient is negative, expression is positive. So, x lies between the roots. So, what is the solution here? 1 less than or equal to x less than or equal to 4. I am writing equality also because equality is given. Now, we want the common interval. How to get the common interval? You locate these two intervals on the real number line. Suppose this is real number line, this is minus infinity, this is plus infinity. Where are the numbers? Smallest number is 1, next is 2, next is 4. The first interval is less than or equal to 2 or greater than or equal to 4. Less than or equal to 2 means minus infinity to 2, including 2. Next, or greater than or equal to 4 means 4 to infinity, including 4. Second one, x lies between 1 and 4, including 1 and 4. That interval will be like this, including 1, including 4. Now, what is the matching interval, common interval? These two are matching here, and only at 4 they are matching. So, what is the answer? What is the solution? One to 2, including 1 and including 2, both square brackets. Union only single number 4. We will write single number with flower bracket. So, this is the answer. Next question. Find the values of a for which x square plus ax plus 1 greater than 0 for all x. When is an expression greater than 0 for all x? The graph must be completely above the x-axis. What is the condition? X square coefficient should be positive, it is positive only. What else? Delta should be negative. So, here you will write delta less than 0. What is delta? B square minus 4ac means a square minus 4 into 1 into 1. A square minus 4 should be less than 0. You can factorize this as a plus 2 into a minus 2 less than 0. What is the interval? If x minus alpha into x minus beta less than 0, x lies between alpha and beta. Therefore, minus 2 less than a less than 2 is the interval of a. Okay. Find all values of a. The values of a are open interval minus 2 to 2. When end values are not included, it is called open interval. When end values are included, it is called closed interval. So, this is the answer. You can also write it as a belongs to open interval minus 2 to 2. Next question. If 4 minus c into x square plus 4x plus 7 minus c is greater than or equal to 0 for at least one real x, find c. Here x square coefficient is 4 minus c, we do not know whether it is positive or negative. If it is positive, then if 4 minus c is positive, then how will be the graph? Graph is an upward parabola. It may be at any position. It may intersect the x-axis or may be above the x-axis or may touch the x-axis. In all the cases, in all these cases, it is greater than or equal to 0 for at least one real x is true, because expression is taking positive values somewhere. Okay. Therefore, it is always true, and if 4 minus c is greater than 0, c is less than 4. So, c is less than 0 is a solution. Okay. Now, when c is greater than 4, sorry, c is less than, c is less than 4 is a solution. If c is less than 4, 4 minus c is positive, then you will get these one of these three cases, then that expression will be greater than or equal to 0 for at least one real x. It is true. So, c less than 4 is a solution. Now, if c is greater than 4, then the graph is downward parabola. It may be like this, intersecting the x-axis, or it may be completely below the x-axis, or it may be touching the x-axis. What are the conditions here? If c is greater than 4, coefficient of x square is negative, so graph is downward parabola. In this case, discriminant is positive because the graph intersects the x-axis. In this case, discriminant is negative. In this case, discriminant is delta is equal to 0. Now, that expression should be greater than or equal to 0 for at least one x. It is possible in this case and in this case. In this case, it is becoming equal to 0 for one value of x. This is not possible. So, here delta greater than 0, there delta is equal to 0. So, the necessary condition is delta greater than or equal to 0. Okay. Delta means what? B square minus 4ac, 16 minus 4 into 4 minus c into 7 minus c. Should be greater than or equal to 0. Simplify, 16 minus 4 into, if you multiply, you will get 28 minus 11c plus c square greater than or equal to 0. Simplify further, you can cancel 4. If you cancel 4, 16 becomes 4. So, 4 minus 28 plus 11c minus c square greater than or equal to 0. Then minus c square plus 11c minus 24 greater than or equal to 0. If you want, you can multiply both sides by minus 1 and write it as c square minus 11c plus 24. Then if you multiply by minus 1, what happens? Greater than becomes less than or equal to 0. Now, is it possible to factorize? This is 8 into 3. 8 into 3 is 24. 8 plus 3 is 11. So, you can factorize it as c minus 3 into c minus 8 less than or equal to 0. What is the solution of c? You know that if x minus alpha into x minus beta is less than or equal to 0, x lies between the roots. So, here c lies between the roots. 3 is less than or equal to c, less than or equal to 8. But already we assumed one condition, C greater than 4. So, we have to correct it. C must be greater than 4 now. So, it cannot take values from 3 to 4. So, we have to correct the interval as four is less than C less than or equal to 8. Okay. Now, if C is less than 4, it is always true. If C is greater than 4, then C should not exceed 8. But what about C is equal to 4? If C is equal to 4, it is not a quadratic equation, but that is not a problem. It should be greater than or equal to 0 for at least one x. If C is equal to 4, what happens? The expression becomes 4x plus 3 if C is equal to 4. If you take the expression as y, it is not quadratic, but its graph will be a straight line. Y is equal to 4x plus 3 is a straight line. It will be like this. Definitely it takes positive values. So, this will be true for at least one real x. So, for C is equal to 4 also this is true. So, finally, what is our answer? All values less than 4 and C is equal to 4 also allowed, and all values lying between 4 and 8. So, union of all these solutions will be minus infinity to 8. So, finally, answer to the previous question is C belongs to minus infinity to 8 including 8. Okay. Next question. An expression is given in x and y. Both x and y are variables. Then find the maximum minimum values of x and y. When x and y are connected by this equation, find the maximum minimum values of x and y. That is the question. Now, we can write this as a quadratic equation in y. Write y square term first. Only one y square term is there. Next, from this and this, you can take 2y common and write it as 2y into x minus 10. Next, write the terms independent of y. What are the terms independent of y? 9x square minus 92x plus 244 is equal to 0. In the question, find the maximum minimum values of x and y. So, x and y must be treated as real numbers. Now, this is a quadratic equation in y, just like ay square plus by plus c is equal to 0. A is 1, b is 2 into x minus 10, c is this entire. Now, if y is real, then the roots of this quadratic equation are real. What is the condition? B square minus 4ac should be greater than or equal to 0 if y is real. What is b square? 2 into x minus 10 whole square, that is 4 into x minus 10 whole square minus 4 into a into c means 1 into this, 1 into 9x square minus 92x plus 244 should be greater than or equal to 0. Let us simplify. You can cancel 4 on both sides. You can divide both sides by 4. Expand the square. X square minus 20x plus 100. A minus b whole square formula. Minus of 9x square minus into minus plus 92x minus 244 greater than or equal to 0. X square minus 9x square is minus 8x square. Next, minus 20x plus 92x is plus 72x. 100 minus 244 is minus 144. Should be greater than or equal to 0. Now, you can divide by common factor minus 8. Whenever you divide by negative number, inequality will change. So, what will you get? Dividing by minus 8, x square minus 9x, 8 9s are 72 now. Next, dividing by 8, how much you will get? 36, not 18. Dividing by 2, 72, 36. 36 by 2, 16. 16 you will get. 36 by 2, 72, 36, 18. 18 you will get. So, plus 18 greater than or equal to 0. Not greater than. When you divide by minus 18, greater than becomes less than. Is it not? Now, how to find the solution of x? Factors are here. You can also solve like this. X square, x is equal to 9 plus or minus root over roots. I am finding the roots. B square minus 4ac is 81 minus 4 into 18. 4 into 18 is 72 by 2. How much are you getting? 9 plus or minus root 9 is 3 by 2. What are the roots? 9 minus 3 by 2 is 3, or 9 plus 3 by 2, 6. If the quadratic expression is negative, less than or equal to 0, x square coefficient is positive. X square coefficient and quadratic expression have opposite signs. Then x lies between the roots. We will get 3 less than or equal to x less than or equal to 6. Then only y will be real. So, maximum value of x is 6, minimum value of x is 3. X minimum is equal to 3, x maximum is equal to 6. Now, how to find the maximum minimum values of y now? You can easily guess what to do. We have to write it as a quadratic equation in x. If you write it as a quadratic equation in x, first you should write 9x square. Next, coefficient of x means we have to combine this and this. You can take 2x common plus 2x into y minus 46. 46 2 are 7, 92 now. Y minus 46. Next, term independent of x. Y square minus 20y plus 244. Y square minus 20y plus 244. The same equation is expressed as a quadratic equation in x. If x is real, what is the condition? Discriminant should be greater than or equal to 0. What is the discriminant? B square means coefficient of x whole square. How much? 4 into y minus 46 whole square minus 4 into 9, 36 into y square minus 20y plus 244 should be greater than or equal to 0. We have to solve. You can divide by 4, then this 4 cancels, this 36 becomes 9. Now you expand. Y minus 46 whole square is y square minus 92 y plus 46 square, 46 into 46, 6 into 46 is 6 6 are 36, 3, 6 4s are 24, 24 plus 3 27. Now 4 6s are 24, 2, 4 4s are 16 plus 2 18. You are getting 6, 11, again 1, 2. Okay, you are getting 2116 minus 9y square plus 9 into 20, 180y minus 9 into 244 greater than or equal to 0. Now you simplify this and find the solution of y. You will get something like alpha less than or equal to y less than or equal to beta. Then alpha is the minimum value, beta is the maximum value. Rest of the calculation you complete so that we can solve more problems. Okay. Next question. If ax square minus bx plus 5 is equal to 0 does not have two distinct real roots, find the minimum value of 5a plus b. This quadratic equation does not have two distinct real roots, means either it has two equal roots or imaginary roots. So what is the condition? Discriminant delta should be less than or equal to 0. Does not have two distinct real roots. If it has two distinct real roots, delta must be greater than 0. If it does not have two distinct real roots, delta must be less than or equal to 0. What is delta? B square minus 4 into a into 5 minus 20a less than or equal to 0. This is the condition given. We have to find the minimum value of 5a plus b. Here this condition can be written as b square is greater than b square is less than or equal to 20a. So we can write 5a is greater than or equal to b square by 4. Can't we write? 20a is greater than or equal to b square. So 5a is greater than or equal to b square by 4. Now this is 5a plus b. 5a is greater than or equal to b square by 4. So adding b on both sides, you will get 5a plus b is greater than or equal to b square by 4 plus b. Is it not? Now take 4 LCM. b square plus 4b by 4. Denominator is constant. Numerator is quadratic in b. In this quadratic, you observe that b square coefficient is positive. In a quadratic expression, if the second degree coefficient is positive, then the graph of the quadratic will be upward parabola. Graph of b square plus 4b will be upward parabola because b square coefficient is plus 1. It will have a minimum value. How to get the minimum value of this quadratic? You have to use the formula 4ac minus b square by 4a. Here a means 1, b means 4, constant c means 0. So, it is greater than or equal to its minimum value. 4ac means c is 0, no? So, 4ac is 0 minus b square means 4 square 16 by 4a, 4 into 1, 4 whole divided by 4. How much you will get? Minus 16 by 4 into 4, 16. It is greater than or equal to minus 1 for any value of b. So, the minimum value of 5a plus b is equal to minus 1. Suppose you are confused with this formula because the expression is also in terms of b. Here I am writing the formula in b, in ABC. If you are not understanding this method, then you can follow squaring method. After getting After getting 5a plus b greater than or equal to b square plus 4b by 4, you can express this as a perfect square and get the minimum value easily. You write it as b square plus 2b. How can you make it a perfect square? By adding 4 and subtracting 4, b square plus 4b plus 4 can be written as b plus 2 whole square. Minus 4 by 4. We know that minimum value of b plus 2 whole square is 0. Perfect square is always greater than or equal to 0. So, this whole expression is greater than or equal to 0 minus 4 by 4. How much? Minus 1. You are getting the answer. Okay. Next question. This model will take time, so I will explain tomorrow because time is only 2 minutes left. So, I will continue from here tomorrow in the next class. Okay. So, with this we have concluded the class and we are going to continue this chapter for some more days, and then after completing quadratic expressions we are moving to next topic. So, in the next class we are going to discuss some beautiful problems in quadratic expressions, and all of you please download the assignments or DPPs, solve them and post your doubts, and don't miss the Sunday test. Okay. So, avail all features of Yupp Master live learning app. Please download Yupp Master app and avail all the features. Okay. Thank you very much for watching. See you in the next class.